So many A-level maths students left this question completely blank. Let's make sure it doesn't happen to you this summer. After marking it, the examiners said that many candidates found this question challenging, and there were a significant number of blank responses. Candidates found Part A particularly challenging, with many attaining either no marks or only the first mark. We've got a tank in the shape of a cuboid being filled with water. The base of the tank measures 20 metres by 10 metres, and the height of the tank is 5 metres, as shown in the figure. At a time t minutes after the water started flowing into the tank, the height of the water was h, and the volume of the water was v, in metres cubed. In a model of this situation, the sides of the tank have negligible thickness, and the rate of change of v is inversely proportional to the square root of h. We're asked to show that this equation holds, where lambda is a constant. How can we get started with this? Well, let's first write down an equation for the volume of water in the tank. That's what they called V. Well, it's a cuboid of water measuring 20 by 10 by h. So the volume is going to be 20 times 10 times h. That's 200h. Now, looking at what we've got here, we need to show where this comes from. Notice it involves differentiation. So I'm looking at this equation and thinking, well, can I differentiate it? Yes, I can. I can differentiate v with respect to this variable h. So I can find dv by dh, that's 200. That gives us our first mark. Next, we can turn this sentence into some maths. So it says the rate of change of v, that's talking about dv by dt, is proportional, but it says inversely proportional. So that word inversely is telling us that we're going to have 1 over. And what is it inversely proportional to? Well, it's the square root of h, as we see here. Remember, that proportion sign, I've highlighted in blue here, becomes equals k, where k is some constant. But we wanted dh by dt. How can we get that? Well, we can use the chain rule. If we leave dh on the top and leave dt on the bottom here, well, it doesn't matter what we put in the other two slots, here and here, so long as they're the same, because they'd cancel one another out, leaving us back with dh by dt. That's the chain rule. Okay, what about dh by dv? Well, we know dv by dh is 200. So dh by dv is going to be 1 over that, 1 over 200. And what about dv by dt? Well, we work that out here. That's k over root h. If we multiply those two things, we get our method mark. And we can simplify this. Look at what we're aiming for. We want lambda on the top and root h on the bottom, where lambda is a constant. Where are our constants here? Well, we've got k over 200. Let's just call that lambda. And what are we left with? Well, the root h is going to be on the bottom. That gets us our final mark. Part B. Initially, the height of the water was 1.44 metres. And exactly 8 minutes after water started flowing into the tank, the height of the water was 3.24 metres. Use the model to find an equation linking h with t. Give your answer in this form, with h to the power of 3 over 2 at the front, where a and b are constants to be found. How can we start this? Well, think about what we worked out in part A. We had dh by dt was this. We can integrate this through the technique of separating the variables. We can separate the variables by multiplying and dividing only. You can't add and subtract. What we need to do is to bring all of the h terms onto one side, and everything else without an h needs to go onto the other side, so the dt and the lambda, say. So let's put them on that side by multiplying by dt, and we'll move the h's onto the other side by multiplying by root h. Notice at this stage we then integrate both sides. So that's the process of separating the variables. Now we can actually do the integration. Remember, lambda was just a constant, just a number. So when we integrate it with respect to t, we get lambda t. Don't forget, whenever we integrate, we need the plus c as well. Let's rewrite root h in a friendlier way. That's h to the power of a half. Now that's ready to integrate. How do we do that? We add 1 to the power to get the new power of 3 over 2, but then we divide by that new power. Dividing by 3 over 2 is the same as multiplying by its reciprocal, 2 over 3. If we do all of that, we get our first 2 marks. What do we do next? Well, we can use the information we were given in the question. It said initially the height of water in the tank was 1.44 metres. That word initially is really important. It means when t equals 0. Here, the height h is 1.44. So we can substitute both of those things at the same time into this equation. That means that the lambda will cancel out, and we're left with c equals this, which we can put into our calculator and write nice and neatly as a fraction, 144 over 125. That gets us another mark. So let's replace this c back into this equation here with the fraction. Exactly 8 minutes after water started flowing into the tank, the height h was 3.25. So when t is 8, remember t was measured in minutes, the height h is 3.24. We can substitute both of those things into this formula, as shown, and then we can solve for lambda. And if you do that carefully enough, you'll end up with this fraction. That gives us another method mark. We can then replace that value of lambda back into this equation here. So replacing the lambda in there gives us this. Finally, we need to make sure that we're following the instructions about the form the question wanted. It wanted h to the power of 3 over 2 equals. So we need to multiply both sides by 3 over 2 to get rid of this fraction 2 over 3. So we multiply this, and this by 3 over 2. If we do that carefully enough, we get this number here, and this number turns into this number. Remember to multiply all 3 terms. That gives us our final mark, part C. Hence, find the time taken from when the water started flowing into the tank for the tank to be completely full. So, what would it mean for the tank to be completely full? Well, it would mean that the height of water would be the same as the height of the tank. h would equal 5. And we're asked to find the time taken, so we want to know what t equals. So we can use the formula that we've just worked out in part B, and we can just replace in that formula h with 5. We can then subtract this from both sides, and then we can multiply by the reciprocal of this fraction, flipping it upside down, multiplying on both sides to isolate t. If we put that into our calculator, we get 18.4. But be careful. To get this final mark, we need to give the units. Remember, the units of time in this question were minutes. If you forget to put that, you would lose the mark. Be careful.